Hello and welcome to Everything Embedded. In this video, we're going to continue on with the design we started in our last video, where we're working on this 24 to 5 volt buck converter. In the last video, we completed the schematic, and now in this one, we're going to walk through the process in KiCad of assigning footprints, and for a few of the footprints, we're going to be building our own footprints. So I'll walk through how to do that, and we'll see that process. So to start with, I'm going to assign all the footprints for ones that KiCad already has in its built-in libraries. So that's going to be some of the standard capacitors and resistors and things like that. And then we're going to go through, there's about 4 parts. We have the banana jack plugs that we're going to use. We have this electrolytic capacitor. We have the regulator component itself. And we have the inductor. Those ones are kind of non-standard. There's not really industry standards for them. So we're going to go through, look at the data sheets, find the footprints, and design our own. For the capacitors, it's important that we select large enough footprints that allow for the DC voltage rating that we need for these capacitors. So some of these ones here are going to be 24 volt at least capable. Some of these other ones are going to be less, so we can get away with smaller footprints for those. I've gone through and selected capacitors for this already. And so here we have a chart here, and so I've picked out so far 4.7 microfarad input caps. I know that we need 1206 size. For our 0.1 microfarad, we're going to use a 402. All of our resistors are going to be a 402 size. For our 22 microfarad, we can use an 0805. For the 33 picofarad, we're going to use a 402, and for the 1 microfarad, we're going to use a 402. So for this, since we're using KiCad's built-in libraries, all we have to do is go run the footprint assignment tool. And so I've got the libraries added already, and so in here, this shows a list of here's all of our symbols in our schematic, and then it has a list of filtered footprints here. And so what we can do, we know C1, this is our 82 microfarad. That's the one we're going to have to build our own footprint for. But our 4.7 is a 1206 cap. And so we have the SMD caps, and then we'll go down to the standard surface mount here and grab the 1206. There's a couple different ones in here. So they have some larger ones. If I expand this out, KiCad comes with these hand solderable footprints. If you're not reflowing your board, these work pretty good for hand soldering, but for reflow, they can cause problems with tombstoning and stuff like that. So we're not going to use the hand solder footprints for this, since I will be reflowing these boards. So for our 4.7 microfarad, we're just going to double click here. That gives us the 1206. For our 1 microfarad, that's going to be an 0402. For our 0.1 microfarads, those are all going to be 0402s as well. For this 4.7, we're also the 1206. For the 33 picofarad, we're in 0402. For the 22 microfarad, we're using 0805s. Those connectors we're going to do custom. I think I mentioned earlier that we were going to make our own one for the inductor, but I actually did find that there is a Coilcraft XXL 4020, which is the series we're using for this 1.2 microhenry inductor, so we can grab that one. And then for our resistors, we'll go into the resistor SMD. We're going to use 0402 for all of our resistors. And then we're going to have to make our own for the package itself. So we've got 3 footprints we need to make. We've got our 82 microfarad cap. We've got our banana jacks. Then we have the regulator itself. So we'll click OK there and save this. And then we can get started making footprints. So to make the footprints, we go to the main KiCad window and open up the footprint editor. In here, we can see the libraries that we've pulled in. So these are the built-in KiCad ones. We don't want to edit any of those, so we're going to need to make a new library. We'll select this as a project library and put this in here. So this will just be our regulator footprints library, and save that. For the banana plugs, I'm using these panel mount banana jacks from Pomona. And so these, the way they install is there's just a 1/4-32 thread on them. And so you can basically just screw them down, and we're just going to use a through hole. And so these will kind of act like feet for our board as well. I wouldn't necessarily recommend doing this for production use. These are normally panel mounted, and then you wire from these to your board. But for testing, these should work just fine. And so what we need for that is a just single through hole that's plated that we can screw our plugs into. So since it's a 1/4-32 thread, we'll look up what the thread clearance for that is, and then we'll just make the width of the pad match the width of the jack here. So this is a 1/2 inch in diameter. So we'll have an outer diameter of a 1/2 inch. And then for our clearance hole, We can go down here. So for a 1/4 inch hole, the free fit, and do the 0.2660. So back over in our editor, we can create a new footprint, and we're going to use an empty one. And then this we will name to just be a banana jack panel mount. Then KiCad creates this, so it gives us a reference designator, the name of the footprint, and this. There's a bunch of different layers here. You want to make sure that the silkscreen layer and then courtyard and fab are all covered, and then there's the copper layer. The silkscreen is what actually shows up on your board, so that's this blue text. The courtyard is used to make sure that you don't have components that are on top of each other. And then the fab layer is used, you can generate drawings to give to your assembler that shows where all the parts go. That's a little easier to understand than the silkscreen, because sometimes you may not have room to put everything you want on the silkscreen. So you can put that on the fab drawing and give that to your assembler. So to start out, we know we need a circular pad. So we're just going to go up here, add a pad, and drop that right in the center here. And then that's the only pad we actually need for this footprint. So we're going to go in here and edit it. We need to be in inches for this, since all of our dimensions are in inches. So it's pad number 1. It'll be the only pad on here. The pad shape is circular, and then the pad size. So this is the outer ring on it. We want to be a 1/2 inch. And then the hole size, that was what we looked up for our drill fit. We wanted to be 0.266. The other thing we want, since we're not soldering to this one, it's just fine to have a solid connection to copper zones. So we can go in here, there's the clearance overrides and settings. So when you fill a zone around a pad, there's the options of adding little thermal reliefs to it. We want this to connect solid since we're not soldering to it. So we will select this as solid. Nothing we need to do there. And all the solder mask clearances should be fine. Now that we have this on here, we need to make sure that our reference designator is not on top of it, so our silkscreen works out. And then I usually put the fab pieces roughly in the middle. There should somewhere in here, there's our ref for that. So I'll put the ref that's on the fab layer here in the middle, and the name right here. And then, so that covers our fab, and then we want to make sure we have a courtyard drawn for this so that we have kind of a keep out around it. So we'll just draw a simple circle. And this will just make sure that we keep parts out of this circle so we've got room for everything. So we'll give us a, change our grid here. Do 1/10 of an inch, so we'll give us a 0.3 radius circle, so we've got a 0.6 land around that on our fab. So then we'll save this, and we want this to go into our regulator footprints library. So that's all we need to do for that one. We can now go back to our layout and assign that footprint. So we'll go back into the footprint assignment tool, and we've got our connectors here, and we've now got our regulator footprints, and so now we can add our banana jack panel mount there. So now we've just got our capacitor and our regulator. So we'll save that. So our capacitor is a good example of a footprint that can sometimes be tricky just from the manufacturer's perspective to find. So here I am on Mauser, I'm looking at the capacitor. And typically you just go open the data sheet and there's a footprint in here. This one does not have a footprint drawing in it. And so worst case, if you can't find one, you can kind of use this and make up some stuff that seems reasonable. There's some IPC guidelines for that. However, what this actually means is that you have to go to Panasonic's website, and there's a separate, if you go look up the part on the manufacturer's website, there's more things than just the data sheet in here. So they've got a data sheet, product catalog, a general catalog of their capacitors, and then under specifications, they actually have recommended soldering and land pattern dimensions. So if we open that document up, this has some soldering information, and then they actually have a land pad info. So from the data sheet here, we can look at the value of capacitor that we're using for the specific part number. So we're using the 35 SVPF82M. So if we go grab the 35 SVPF82M, we can see that that is in the E12 package size. So now we go back over to soldering spec, and they have the E12, and then this is the LAN pattern for it. So we'll have to use this LAN pattern as well as the other data sheet to fully create our footprint. So once again, we create a new footprint, and then this will be a pan for Panasonic, cap E. So that way it's their capacitor and it's their E size footprint for Panasonic. So one trick I like to do when I'm dealing with something like this that has a whole table of things is just to keep the dimensions straight. I'll often just grab like a snip in the snipping tool and fill it in. So with the snipping tool, I can go grab a little thing, and then now I can look at the table and fill these dimensions in. So I know for the E12, this A is 2.8. The C dimension is 1.9. And then the B dimension is 11.1. So this will give us kind of our reference piece for this, and then we can fill the math in because we need to know the size of the pad. So we actually need to know the distance here. And then we need to know the distance from the center of the pad, which is here, to the center of the part. And so that'll be here. So we need to fill in those two dimensions before we can go create our part. And so for this top dimension here, that works out to being 11.1 minus the 2.8. So that takes this whole dimension here and subtracts out the 2.8 from it, which gives us the width of the two pads. So then if we divide that by 2, we get 4.15. And then we know our 1.9 is already there. For this other dimension here that gives us our distance, we know it's half of the 2.8 to get us here, and then half of the width of the pad. So if we take our 4.15, we add 2.8 to it, and then divide it by 2, then we get 3.475. And so those are the dimensions we'll need to create where the pads go. So now we're going to go grab our pad, place that, and we need to make this a rectangular surface mount pad. So we'll edit the pad with E, change it to an SMD type pad. It's going to be pad 1. And then we actually need to be now in metric. So all the dimensions for this data sheet are in millimeters. So we're going to go to millimeters. And now back to edit. So our position in the X we know needs to be negative 3.475. Our position in the Y we want to be 0. Actually, for this one, we're going to go with a rounded rectangle. The corner size will go 15%. And then the pad size in the X dimension we know is 4.15. And in the Y, the Y was listed as 1.9. So that creates our first pad. And then to do our second pad, we're just going to duplicate this. We'll move it over, edit this one. It's now going to be pad number 2. And then its position we'll just set to be at the 3.475. And then the rest of the settings we can leave the same. So that leaves us with our pads in place. We need to change our grid size down now. I like to work maybe at about 0.1 millimeters for this next step. First, we'll just move our text so it's in position. And then we're going to come back over. Instead of looking at this, we're actually going to look at the data sheet itself that has the sizes of the package. So I actually want to put an outline of the package here on it so we know kind of what the part looks like and how to orient it on the board. So the first piece I want to put on is this, I want to put a circle that represents kind of the can piece of it on the fab drawing. So that we have this we can see here it's an 8 millimeter diameter circle for that. So over in KiCad, we'll go to the fab drawing, and then we'll grab our circle tool. We'll set our grid to 1 millimeter and draw out a 8 millimeter diameter circle. Next, we want to get the outline of the part here on the fab drawing. So for that, we have a width and a height of 8.3. So we'll grab the line tool. Actually, to start, we'll grab a rectangle. We'll use this kind of as a reference, and we'll actually just put it on the back fab, and then we'll delete it later. So to make this easier, we're going to round up to 8.4, which means we then need 4.2 for our dimensions. So I'm looking down here in the bottom at my X and Y dimensions are listed down here as I move my cursor around, and so that makes it really easy to measure stuff out. So since I want to be at 4.2, and then come down to Y, right there's 4.2, and then we'll just make this a rectangle that we'll have as our reference. So it'll be an 8.4 by 8.4 millimeter rectangle. So that'll give us kind of a reference to work off of. And then on the plus end, which is pin 1, it has these little chamfered sides on this. So now we can draw that in on the fab layer and actually get the outline correct. So what we'll do is just grab the line tool, we'll go on the front fab, zoom in here to make this a little easier to see, and then we'll just make those chamfers be we'll make those 1 millimeter chamfers. So to make that measurement, I go up to the corner here and then press the space bar, and that zeroes out these DX and DY indicators down here. So now I can look at the change between where I zeroed it out. So we'll come down here 1 millimeter, and then now in the DX we're 1 millimeter, and then we'll just match this outline all the way around. I know I need to come up 1 millimeter from here, so I'll use that same trick and we'll zero out there and come up until we're at 1 millimeter, and then we'll finish off and then go and right click and go to cancel here. So that gives us our shape there on our fab layer. So that helps tell us where everything's at, and now we can go delete this rectangle that's on the back fab that we were using as a reference. Next on this, to make it super clear to the assembler, we want to put on the fab layer a plus sign on pin 1, since that's going to be the positive side of this capacitor. So we'll just go over here and draw in a very simple little plus and even that guy out. So that covers our fab layer. Next, on the courtyard, we want to make sure nothing gets stuck kind of inside the footprint of this so that things don't interfere. And so for that, for something like this that's pretty basic, just a simple rectangle all the way around it that keeps things off of our pads should be good. So we'll just do a basic rectangle around that encompasses all the pads. Next, we want to get our silkscreen. And so this is what will actually be the white text that's on the circuit board. And so for this, we're going to want pretty similar to our fab drawing, except for usually we want to go a little outside the component edge, and that ensures that you can kind of inspect it and see that everything's correct when the component's down. And you also don't want silkscreen on the pads. Most tools will automatically take it off the pads, but it's kind of good practice just to not put it there in the first place. So we'll go just on the outside of where our pads are at and draw a line all the way around here, just like we did with the fab layer. And so we'll just use that one as kind of our reference layer. So that takes care of one. And then we'll draw one around this side as well. So now we've got our silkscreen around this, and then on the silkscreen layer, we also want to have the plus, so we make sure that the component gets set up right. So we'll go do the same thing there and just put a plus on top of that one. And that'll kind of guarantee that everything gets set up right on the board, and we should be good to go. So we'll save this footprint out. This is our pan cap E. We'll put this into our regulator footprints, and then we can go back to our schematic view and assign this one. So now we'll grab our 82 microfarad cap, and we'll grab our regulator footprints, and we've got this cap here, so we can add that one. The last footprint we need to do now is the regulator itself.